So now we know how to solve equations that involve absolute values. What about inequalities? Let's start with a simple one. Let's suppose we have the inequality, the absolute value of x is less than 5. And let's take a moment and think about what absolute values mean on the number line. So here's a number line with 0 in the middle. And remember, absolute value describes a number's distance from 0. What are the numbers whose distance from 0 is less than 5? Well, we have some positive numbers, right? All of these numbers are less than 5 away from 0. For example, this number is about 3.5 away from 0. Less than 5. Oh, the distance from 5 to 0 is exactly 5. So its absolute value is not less than 5. But anything smaller than 5, that's in. We'll write a round bracket out here at 5. 5 isn't in, but everything smaller than it is. How about over this way? 1, 2, 3, 4, 5 away. Over here we're at negative 5. Again, negative 5 is too far away, so it's not in. But everything above it is. Oh, I think I see something. I can rewrite the inequality, the absolute value of x is less than 5, as saying that x is somewhere between negative 5 and 5, right? Will that work out in general for absolute value inequalities? Let's come up with something, I don't know, a little bit weirder. Let's say we have 2x plus 1 is less than 3. Well, this says the distance from 2x plus 1 to 0 is less than 3. How can that happen? 2x plus 1 has to be at the same time less than 3, so it can't be too far off to the right. And more than negative 3. It can't be too far off to the left. Yeah, I think that'll work in general. And now this is just a between inequality. We can solve this in the usual way. We see that the absolute value of 2x plus 1 is less than 3, exactly when negative 2 is less than x is less than 1. And we can also see, in general, how to rewrite an absolute value inequality. At least one involving less than. If we have an absolute value inequality that says the absolute value of some expression is less than some positive number, we can rewrite that as the opposite of our positive number is less than our expression, and our expression is less than the positive number. Same thing goes for less than or equal, except they're less than or equal after we rewrite. Right? Again, this only applies to absolute value inequalities with less than or equal. We'll see what to do with greater than or equal in a subsequent video. But the reason that this works this way, right, is when we say the absolute value of something is less than a number, that's telling us that our expression is in close to 0. I'm going to have you try one of these. Solve the absolute value inequality. The absolute value 5x minus 8 is less than or equal to 9. Pause the video and try this now. Alright, so we'll rewrite this as 5x minus 8 is between negative 9 and 9. And now this is just an ordinary betweenness inequality that we can solve like any other. We'll add 8. 9 plus 8 is 17. We'll divide by 5, again in all three places. And we get negative 0.2 is less than or equal to x is less than or equal to 3.8. And that's all there is to it. Now, maybe we want to express your answer in interval notation. What would that look like? Pause the video and try that now. Well, if we'd like, we can sketch this on the number line to see what our interval notation will look like. Go ahead and do that if you'd like, but just looking at this inequality, I see the smallest possible value of x is negative 0.2. The largest possible value of x is 3.8, and they're both included because these are both less than or equal to signs.